Hey everyone and welcome. So if you're a new data science grad, first of all, congrats. You're stepping into an amazing field. But let's be real, you're also facing a pretty tough job market, right? And it's one that's being completely reshaped by AI. The big question on everyone's mind is, where do I fit in when an AI can write code? Well, today we're going to give you a whole new playbook for not just surviving, but actually thriving in this new world. And just a heads up, my colleague Rajan is going to be back with a hands-on demo to show you all of this in action. Let's dive in.
This quote right here, this is everything. It's the theme for our entire explainer because it just perfectly captures the shift we all need to make. This isn't about AI being a threat to your career, not at all. It's about the single biggest opportunity you're ever going to have to leapfrog from junior-level thinking straight to architect-level value, right from day one.
Okay, so first things first. We just have to accept the new reality. AI can write SQL. It can write it well, it can explain it, it can optimize it, and you know what? It's getting better every single day. This is not some future prediction anymore. This is a fact, right here, right now.
And just look at how good these tools have gotten. I mean, they can spin up complex queries from plain English in a few seconds. They can take that ancient, monstrous query that nobody on the team understands and explain it instantly. They'll suggest optimizations, fix weird errors, and even translate SQL between different systems like SQL Server and BigQuery. The big takeaway here is this. The purely mechanical skill of just writing basic SQL, yeah, that's pretty much automated now.
Okay, so if the mechanics are automated, where do you come in? This is the most important part of our whole conversation. We need to pivot hard and focus on the massive gaping holes in what AI can do. Because those gaps, that's where your human expertise becomes more valuable than it has ever been before.
First and foremost, AI has absolutely zero business context. You can tell it to calculate revenue, but it has no idea if your company's definition of revenue is supposed to include refunds or not. It can query for active users, sure, but it doesn't know that your business defines an active user as someone who actually completed a key action, not just someone who logged in. That context, that's your superpower.
Next up, AI cannot make architectural trade-offs. It might suggest, using a super powerful tool like Spark for some task, but it can't weigh the real-world factors. It doesn't know your team's skill set, or your project's budget, or your company's bigger cloud strategy. Choosing the right tool isn't just a technical decision, it's a business decision, and that's a human's job.
Oh, and this one is huge. AI cannot evaluate data quality. It will happily write you a perfect-looking query that joins two tables, completely unaware that some pipeline bug last week created thousands of duplicate customer IDs in one of them. A human with that domain knowledge would spot that anomaly in a heartbeat. The AI, it would just give you a dangerously wrong answer with a smile.
And finally, AI cannot exercise judgment. Knowing when a solution is good enough versus spending another week to make it perfect, that's a uniquely human skill. Understanding when to prioritize speed over absolute accuracy, or when to tell a stakeholder that their request just isn't worth the engineering effort, that's judgment. AI has none of that.
So, all of this brings us to the big shift in mindset. To really thrive, you have to stop thinking like someone who just writes queries and start thinking like a solution architect. It's a fundamental move from focusing on lines of code to focusing on the actual business problem you're trying to solve.
This slide just illustrates the difference perfectly. The junior mindset is, what's the right answer? It feels like you're constantly being tested. But the architect asks, what's the right approach? They see it as a collaborative problem-solving session. It's the difference between writing one perfect query and designing a whole robust solution.
So, what's the number one tool in an architect's toolkit? It's not a piece of software. It's the clarifying question. Let's imagine this scenario. Your CEO sends you an email that just says, "Why did retention drop?" A typist immediately panics and starts writing queries. An architect, on the other hand, starts asking questions. And look at these questions. They have nothing to do with code, do they? They're all about context. Wait, what do we actually mean by retention here? Is this drop affecting everybody, or just, say, new users from that last ad campaign? Did we change our pricing last month? These questions dig for the real problem before you even think about writing a single line of SQL. This is where you create all the value.
Now let's talk about how this whole mindset translates directly into getting you a job. Because I promised you, you will be asked a version of this next question in an interview, and your answer could make all the difference.
There it is, the question that's designed to figure out if you're a typist or an architect. But listen, don't see this as a threat. See it for what it is, the perfect opportunity, a total softball question that lets you show them exactly how you think.
So here's your game plan, a simple 4-step framework. First, you acknowledge the reality. Show them you're modern and you embrace these tools. You say, oh yeah, AI is an incredible tool. I use it every day. Second, you differentiate your value. You explain that AI writes code, but you solve business problems. Third, you illustrate this with a quick example, just like that retention drop mystery. You could say, for example, AI can pull the retention numbers, but it can't know the marketing team just launched a new campaign that could be the real root cause. And finally, you close with a powerful analogy. The calculator one is perfect. You say, calculators didn't replace mathematicians, they empowered them. AI does the same for me. It handles the mechanics, so I can focus on the strategic thinking.
So you see, it all comes down to this. The rise of AI isn't some random event that's just happening to you. It's presenting you with a really clear choice for how you're going to build your career starting today.
And because AI handles all the simple, mechanical stuff, it makes the hard stuff, the truly human stuff, infinitely more valuable. Your ability to understand the business, to break down vague problems into smaller pieces, to have that gut feeling when data just feels wrong, to communicate your findings clearly, and to exercise real judgment. These are the skills of the future. This is your new curriculum.
So I'll just leave you with this final thought. AI is a tool, an incredibly powerful one. It will absolutely replace the work of the data typist, but it will be a massive force multiplier for the data architect. The choice of which one you become, well, that's entirely up to you. Thanks so much for joining us for this explainer.
Hi guys. Okay, so let us see the demo now. So today I'm going to show you practically how we solve the business problems while you are thinking like an architect, not as a junior developer. Let's say the business question comes like show me the top 3 products by revenue in each category for last 12 years. I'm taking this last 12 years because I have slightly older data in my database. I have something like 2014 for my order date. So you might usually have like 12 months, like last 12 months, But anyway, we just want to see like how do we think about solving the business problems and how not to think like a junior developer. Okay, so when this kind of problems comes, like when somebody asks you to solve these things, like here is how you will approach it as an architect. And you will have to prove that you are thinking like an architect. I mean, you don't have to be having like many years of experience working in some particular organization or anything like that. It's just a thought process, how you approach the solution, how you approach this kind of problems. Okay, so you will start asking like clarifying questions. This is how you will approach it. Like you will say like last 12 years. Are you talking about like calendar years or financial year, or what do you want actually? So ask this kind of questions. Like revenue means what? Is it like based on the list price or actual sale price or what? Then like if there is a tie on the third place, then what do you want? You want the any product, or you want particular product to be shown, or what? Then should category with fewer than 3 products, should I show it or should I not show it in the final result? Do you want to see it or not? Right? And what do you want me to do? Like this kind of clarifying questions, you will be able to show that you are thinking like an architect. Okay, and then now once you have all these answers, let's say you try to get it all these clarifying questions answered by them. Now you are not don't write any. The important thing here is not to start typing. Don't write any query. Okay, don't start writing the query. The most important thing. Otherwise, that will make you look like you're a junior. Okay, and that's where the AI replacement and all that fear comes in. Now you have all the answers. Let's say they say last 12 months from today. Okay, revenue is quantity by price. this is how you calculate it, and show the ties if there is a third place. So then you know that okay, you are going to use dance rank. Then you say yes, show categories with fewer than 3 products. They say yeah, even if there are only 2 products, then also you show that category. Okay, so then now you start designing the solution. You're still not writing any SQL or any particular language. You're not coding that thing. Okay, this is the main difference. Then you start designing your solution. You say that okay, what all things you will need. It looks like this is the top n per group, right? So you need top 3 products per category. So this is the top n per group kind of. This is the pattern. Okay, so this pattern, this solution you will need. So then you will think that okay, what all things you will need to do. So you will need to join to get the category information. You have the order details, order header. Now I'm using the OLTP database. It is not OLAP database, so I have the OLAP order header detail in all those tables. So I'll need to do the join with category information. I'll need to aggregate the revenue. Then I'll have to use the window function for ranking, and I'll need the city, and finally to get the top 3, I'll use the filter. So the most important thing here is that you haven't written any SQL yet. Okay, you're just designing the solution. Okay, this is the main difference. Otherwise you look like a junior. Okay, so now once you have designed the solution, okay, you know now what you are going to do. Now you can this is actually what I have in my database. Like I have this many orders, 31,000 roughly, and this is the other details, 504 products and 4 categories. Now how you will write it is like first thing. Now this is also like little bit important, how you are going to, based on how you design the solution. So first thing you will try to get filter. First thing you only want, like let's say last 12 years or 12 months, in our case 12 years. Then we are getting it like this one. You write we are getting only the sales data for that much period only. Okay, now today we are getting this 12 years before. We are calculating the revenue using this formula that we saw they provided, they told us, joining order and header details. Then we are aggregating the revenue by product in another CTE, right, from that sales data that we created here. Then third thing we are doing is we are adding the product and category details. Now we are making the joins here, the joining with product subcategory and product category. Then we are doing the ranking within the categories using the dance rank function. So this one basically gives the same ranking if they have the same total revenue. So once we have done this ranking, now we need only the top 3, right? So for the final output we are doing the rank less than or equal to 3. So this is how we do the final ranking, and we got the, when we run this thing, we get this output, right? So for each category, like accessories, this hitch rack for bike has this revenue, this. So So this is how like your thinking will make the difference. So they will try to like see how confident you are, and then they will say like some questions like why should I not hire like I can do it with AI and all that thing. So this is how you prove that okay, you can do the certain things with AI. AI can definitely help with writing this query, but you need still the overall orchestration and design and everything, right? This is how you think about it. You get all these clarifying questions and all these things. AI will not be doing it as good as you will be doing it. And I mean, if time comes like and if you have to like give them an example or something like that, you can tell them that even like in the office you might have some peon. You will understand the English. Like you can say that, okay, bring me a glass of water. He will bring you the glass of water. That does not mean that you make him the CEO, right? He understands English and he can do certain things. But what the CEO can do and what the peon can do, there is a difference. Now you can say that, yeah, you can train the peon to become the CEO. It's the same thing with AI. Okay, so this is how you will have to basically like um, you tell him that what's the difference if they hire you or they hire the AI. Okay, they get things done by AI agent, but and then ultimately you leave it on them. I mean, whatever they, because they are going to do finally whatever they've decided. Okay, there's nothing you can do about it. But when they are asking you this kind of like to see your like just want to see your confidence and all, then this is the difference that you will have to tell them. So again, the same thing with like we could have like if there are millions of rows here, we might be using like the Spark SQL, right? So the query will be distributed among many nodes, and then it's aggregated, and the final results comes and all that thing. But ultimately, the syntax will be a little bit different. But here, the important thing to understand is we are not at all focusing on the syntax. We are saying that our value is in here in designing the solution and how we uh, like approach the solution, and this is what we are talking about. So once they understand that you have these skills, then they will know that okay, whatever tool they gave you like Snowflake, or there are so many databases, right? We are working in the BigQuery, Azure, anything. Once you have this thing, they will know that yeah, they can like whatever tools they are using, they can give it to you, and you'll be confident on that one. Okay, so okay, now let's talk about the interview questions and answer. Let's practice on that one. Okay, bye.
Welcome back to the deep dive. Today, we're kind of staring into the abyss. And I don't mean that melodramatically. I mean, we are looking at a fundamental existential crisis that I think a lot of data graduates and honestly even mid-level engineers are feeling right now.
Oh, it is the elephant in the server room. It's this creeping anxiety that maybe, just maybe, the machine has finally come for our jobs.
Exactly. We're talking about the reality that AI tools, ChatGPT, Copilot, Claude, whatever flavor you prefer, they can now write perfect SQL syntax in seconds. I mean, you type in a prompt like, give me the top 5 users by revenue, windowed by region, filtering for nulls, and boom.
It's just there.
It's there. The joins are correct. The syntax is clean. It even comments the code for you. So the question on everyone's mind and the core mission of our deep dive today is the entry-level data job dead?
It's a completely valid fear. I see it in the eyes of literally every junior candidate I interview.
Yeah.
But I'm going to push back on that immediately and pretty aggressively. The typist job is dead.
The typist job.
Yeah, the typist. If your value proposition to a company is just that you have memorized the syntax for a left-outer join, or you know exactly where the comma goes in a case statement, you are in trouble. You are obsolete.
Wow. Okay, that's a bit harsh.
It is harsh, but it's the reality. However, the architect role, the person who knows why we are doing the join, where the data is actually coming from, and what it means for the business, that role has never been more valuable. In fact, it's more valuable because of AI.
Okay, I like the sound of that. So moving from a typist to an architect, that's our theme today. We're going to take you, the listener, from this mindset of I know code to I solve problems.
Precisely. We're looking at a whole stack of source materials today that argue a pretty bold thesis. In 2026, knowing how to write a query is just table stakes. It's the baseline. It's like knowing how to type in English. The high-value skill, the actual thing that gets you hired and promoted, is knowing which query to write, where to run it, and why it solves a business problem.
Before we really start unpacking all of this, I want to give a massive shout out to Rajan.
Yes, absolutely. That is essential context.
Rajan provided the hands-on demo that really set the stage for this entire conversation. The materials we're diving into today, covering everything from AI copilots to these complex business scenarios, they really build on that foundation. So thank you, Rajan, for laying the groundwork there.
Yeah, we really couldn't do this deep dive without that practical starting point.
So here is our roadmap for the hour. We are going to break down this shift from query writer to architect. We're going to give you a framework for choosing tools because there are so many of them now, and frankly, it's confusing. We'll do a reality check on what AI can and cannot do, getting deep into the weaves of context blindness.
This is the best part.
It really is my favorite part. We are going to walk through 5 real-world business scenarios. These are the kinds of things that absolutely crush interviews if you get them right, and, well, embarrass you if you get them wrong.
These scenarios are where the theory hits the pavement. It's where you see the stark difference between a junior answer and a senior answer.
Right. So let's jump into part 1, the shift. You mentioned the typist versus the architect. Break that down for me. What does that actually look like in the wild? Because architect sounds like a title you get after, I don't know, 20 years of experience. Can a new grad be an architect?
Absolutely they can. It's a mindset. It's not a job title. Picture an interview room. A junior candidate, let's call him the query writer, walks in. Their main goal is to prove they know the code. They're desperate to show you they know how to use a window function like rank or how to handle a null value with coalesce.
They're basically showing off their vocabulary. They're reciting the dictionary to you.
Exactly. They are showing you the mechanics. They're proving they can speak the language. But then the architect candidate walks in. They know the syntax, sure. But they aren't trying to prove they can code. They assume that's just a given. They're trying to prove they can design a solution.
Give me an example of the difference in that dialogue.
Okay, so I'm the hiring manager. I ask, how would you get the monthly revenue? The query writer immediately says, oh, I'd select the sum of revenue and group by month. The architect candidate pauses and says, well, where is the data stored? Is it in Postgres or Snowflake? Because if it's in Postgres and the table is huge, that aggregate query might kill production. Do we need this in real time, or is a daily materialized view sufficient?
Oh, I see. The query writer just answers the prompt. The architect questions the premise of the prompt.
Completely. And this brings us right back to the AI threat. A query writer is terrified of AI because AI is literally a better typist than they are. It's faster, it makes 0 typos, it knows every obscure function in the documentation.
Right. If your only value is typing fast, you're competing with a machine that types at the speed of light. You're going to lose that race every single time.
Precisely. But the architect looks at AI and sees a force multiplier. They see a tool that handles the grunt work. AI can generate the boilerplate code. It can explain complex legacy queries written by someone 10 years ago. It can even fix your syntax errors. But what AI cannot do is understand the business context.
It doesn't know the politics.
Exactly. It doesn't know the office politics. It doesn't know that the data quality in the transaction table is complete garbage because of a bug push last week.
So the mantra for today really is the typists are worried, but the architects are excited.
That is the tweet right there. We want to transition your mindset from I need to show I can code to I need to show I can solve problems.
Okay, but this implies that there are choices to be made. If I'm just writing a query, I usually open the tool I'm given by the company and I just write. But you're saying the architect actively chooses the tool.
Yes. And this is honestly where most graduates fail. They have a favorite hammer, usually whatever they learned in their boot camp or their master's degree, maybe Pandas or Postgres, and they treat every single problem they encounter like a nail.
I know Python, so I will process this 100 terabyte data set in Python on my local laptop. And then, of course, their laptop melts.
It literally melts. This takes us to part 2, which is the architect's framework. This comes straight from the architect's toolkit source material. It suggests that instead of just grabbing the tool you know best, you need to evaluate the problem across 5 specific dimensions.
Let's walk through these, and I want to get technical here. Don't just give me the buzzwords. Explain the actual physics of why these dimensions matter. What is the first one?
The first one is data volume. Are we talking about thousands of rows, like an Excel sheet or a small Postgres database? Or are we talking trillions of rows, petabytes of data?
Okay, obvious question though. Why does volume dictate the tool? Why can't I just put a petabyte of data into Postgres if I have a big enough hard drive?
It's a physics problem. Traditional databases like Postgres are usually row-oriented. When you read data, the physical diskette or even the SSD controller seeks to a location and reads an entire row of data. If you have a trillion rows and you want to do an aggregation, like finding an average, the physical I/O, the input-output operations required to read all that data will literally take weeks. It is I/O bound.
So you don't use a dump truck to move a potted plant, and you definitely don't use a shovel to move a mountain.
Exactly. Dimension 2 is velocity. Do we need the answer in real time? Think about fraud detection. If you catch the fraud an hour later, the money is already gone. Or is tomorrow morning completely fine, like a daily sales report for the executives?
And speed costs money, right?
Exponentially. Processing data as it arrives, which we call streaming, requires keeping the state in memory. It requires complex windowing logic and highly available, expensive infrastructure. Batch processing, on the other hand, doing it overnight, is cheap. You can spin up servers when electricity and spot instances are cheap, run the massive job, and shut them completely down. So the architect asks a very important question. Do you really need this in real time, or do you just want it in real time?
That feels like a dangerous question to ask a stakeholder.
Oh, it is. But it saves the company millions of dollars, which makes you very valuable. Dimension 3 is variety. Is the data clean, structured rows and columns? Or is it a massive mess of JSON files, server logs, and unstructured text?
The messy reality of the real world. Schema on write versus schema on read.
Exactly. Traditional databases hate variety. You have to define the schema strictly up front. If the data format changes even slightly, the load pipeline fails. Big data tools are often schema on read. You just dump the raw data now and figure out the structure later when you query it.
Okay, what's dimension 4?
Users. And this one is so often overlooked by juniors. Is this for a dashboard that 1,000 people are going to load simultaneously at 9 a.m. on Monday? Or is it for one single data scientist doing a deep, complex, exploratory analysis?
You're talking about concurrency.
Yes, concurrency. If you have a traditional data warehouse and 1,000 people hit it at the exact same time, you might experience severe queuing. Everyone just sits there waiting for their query to run. If it's a transactional database, you might actually lock the rows and bring down the customer-facing application entirely.
And the 5th dimension.
Business criticality. Is this a financial report for the CFO that absolutely must be accurate to the very last penny? Or is this an experimental data science analysis where being quote-unquote close enough is perfectly fine?
Okay, so we have these 5 dimensions. Volume, velocity, variety, users, and criticality. How do we actually apply them? Is there a rule of thumb or a mental model we can use?
There's a decision tree. Let's run through it together. Imagine you have a data set. It's less than 1 terabyte, and it's highly structured. What do you use?
I'd say you just stick with a traditional database, right? Like PostgreSQL or SQL Server.
Perfect. It's reliable, it's fast for single record lookups, and it supports transactions. Now, what if it's greater than 1 terabyte and it's really heavy on analytics and aggregations?
That feels like cloud warehouse territory to me. Snowflake, BigQuery, Redshift.
Exactly. Now, what if you have massive, messy data that requires really complex transformations like joining 100 tables, heavy procedural processing, or machine learning pipelines?
That sounds like a job for Spark SQL.
The heavy lifter, yes. What if you need sub-second results? Everything has to be real time.
That's streaming SQL. Tools like Kafka or Flink.
Good. Now, what if you want open data? No vendor lock-in, just raw files sitting in cloud storage, but you still want to query them like a regular database.
That is the lakehouse architecture. Iceberg, Delta Lake.
You've got it. That is the architect's mental map. But we can't just list them off. We need to go deep into each one. This brings us to part 3, the SQL tool deep dive.
Yeah, I want to double click on some of these tools because the source material goes deep into the why and the when, which is what we're focused on. Let's start with the classic. Traditional databases. PostgreSQL, SQL Server, Oracle. Why do we still use these in the age of big data? Aren't they basically dinosaurs at this point?
Not at all. They are the absolute bedrock of the internet. The key word you need to know here is ACA.
ACID. Break that down for us.
Atomicity, consistency, Isolation, durability. It basically means the database guarantees that transactions are processed reliably no matter what. If you're building a banking application and you transfer $100 from account A to account B, two physical things have to happen. You subtract from A and you add to B.
Right, two separate operations.
If the server loses power exactly halfway through after subtracting from A, but before adding to B, ACID guarantees that the money doesn't just disappear into the void. Either both operations happen, or neither operation happens, it rolls back. Early big data tools were notoriously bad at this. They traded consistency for raw speed and scale. Postgres prioritizes data integrity above everything else.
So they are great for applications where state matters. But they're bad at what?
Petabyte scale analytics. We touched on this earlier. Row-oriented storage. If you try to run a query summing up 1 billion rows of sales data on a single Postgres server, the system has to read every single row and every column in that row from the disk. It will lock up the CPU, it will consume all the available RAM, and the customer-facing application connected to it will simply time out.
So the customers literally can't log into the website because some data analyst is running a big query in the background.
Exactly. And in the real world, that is a fireable offense.
Yeah. So that is exactly where the cloud warehouses come in. Snowflake, Google BigQuery. What makes them so fundamentally different? Is it just that it's Postgres running on a much bigger server in the cloud?
No, it is a completely different architecture from the ground up. There are two main paradigm shifts. First is columnar storage. Instead of storing data row by row on the disk, they store it column by column.
Explain the practical benefit of that to the listener.
Say you have a customer table with 100 columns, but your query only wants to find the average of the price column. A row-oriented database still has to physically read all 100 columns off the disk just to get to the price data. A columnar database reads only the blocks on the disk containing the price column. It completely ignores 99% of the data. That makes it magnitudes faster for analytics.
And the second major innovation?
Separation of storage and compute. This was the real revolution in the industry. In the old days, if you needed more processing power, more CPUs, you had to buy a bigger physical server, which meant buying more hard drives too. They were tightly coupled in the same box.
The classic appliance model. You buy a giant rack from Teradata.
Right. Now, in a system like Snowflake or BigQuery, the data lives in cheap, scalable object storage, like Amazon S3 or Google Cloud Storage. Storing it costs pennies. When you run a query, the system spins up a cluster of compute nodes just for that specific query. They reach out over the network, pull the data they need, process it, give you the answer, and then shut down.
So you're effectively renting a massive supercomputer for 30 seconds, paying for just those 30 seconds, and then returning it.
Exactly. And it allows for infinite concurrency. You can have the marketing team running huge, complex queries on Compute Cluster A and the finance team running their end-of-month reports on Compute Cluster B. They were looking at the exact same underlying storage, but they're using completely different processors. They do not slow each other down.
That perfectly solves the analyst crashing the production app problem.
Completely solves it.
Let's pivot to Spark SQL. You called it the heavy lifter earlier. I feel like Spark scares a lot of people. It feels overly complex compared to just writing SQL in a warehouse.
It is complex. Spark is a distributed computing engine. It's designed for when the data is just too massive for any single computer to hold in memory, or when the transformations are highly procedural.
How does it actually work under the hood?
It breaks your data down into partitions and spreads those partitions across hundreds or even thousands of worker nodes. But here is the catch, and this is what real architects know. You have to understand the shuffle.
The shuffle. It sounds like a dance move.
It is the absolute network killer. Imagine you have data spread across 100 different computers in a rack, and your query wants to join table A and table B by the user ID. User number one's data for table A might live on computer 5, but user number one's data for table B might live on computer 50.
So they literally can't join locally. The processor on computer 5 doesn't have the other half of the data.
Right. So Spark has to send that data across the physical network cables from computer 5 to computer 50 to match them up. That moving of data over the network, the shuffle, is the slowest, most expensive part of any distributed system.
So the architect's job isn't just to write the join, it's to minimize the shuffle.
Exactly. You filter your data as early as possible. You broadcast small tables to all nodes so they don't have to shuffle. You physically design the query execution plan to keep data local to the node. A query writer just writes a join and hopes for the best. An architect optimizes the physical execution plan to prevent the network from choking.
That is a crucial distinction. Okay, let's talk about streaming SQL.
Streaming is fascinating because it completely changes the mental paradigm. It treats data not as a static table sitting on a disk, but as a river, a never-ending continuous flow of events. Tools like Flink or KSQLDB allow you to write standard SQL queries against that moving river.
Give me an example, like show me the average spend in the last 5 minutes.
Right, and as new data flows in every millisecond, the result of that query updates instantly. But this introduces a huge challenge state management. If I want the average over the last hour, the system has to somehow remember all the events from the last hour in its active memory. If the server crashes, does it lose all that memory?
That sounds incredibly fragile.
It can be. Architects have to worry about checkpointing, distributed state, and recovery protocols. You don't use streaming just because it sounds cool or modern. You use it because the business value of the data decays rapidly. Fraud is the classic use case here. A credit card transaction is either valid or fraudulent right now. Knowing it was fraud tomorrow morning is completely useless. The money is gone.
That makes sense. Now, let's look at the lakehouse. This feels like the biggest buzzword of the last 3 or 4 years. Delta Lake, Apache Iceberg. What is the actual tangible value proposition here?
It's the ultimate hybrid. For a long time, the industry was split. You had data lakes, which were just extremely cheap storage, usually messy files, CSVs, Parquet. People called them data swamps because they were so hard to manage. And on the other side, you had data warehouses, expensive, highly structured, but totally proprietary. You locked your data into their ecosystem.
So the lakehouse says, why not both?
Exactly. You store the data cheaply in open source file formats like Parquet directly on Amazon S3 or Azure Blob, but you add a metadata layer. That's what Iceberg or Delta actually is, that sits right on top of those files. It acts like a highly organized librarian. It tracks exactly which files belong to which table. It manages schema versions. It handles concurrent writes.
So you get all of the fancy features of a warehouse like AC transactions and time travel, but you're paying the rock bottom cost of a data lake.
Yes. And critically, this is the most important part for an architect, no vendor lock-in. If your data is fully loaded into Snowflake's proprietary internal format, you can only use Snowflake Compute to read it. If you ever want to leave Snowflake, you have to pay a massive compute bill just to export your own data.
Ah, the Hotel California problem.
Check out anytime you like, but you can never leave. With a lakehouse using Apache Iceberg, the data is just files sitting in your own cloud bucket. You can use Spark to clean it. You can use Trino to run ad hoc queries on it, and maybe you still use Snowflake to do heavy analytics on it. But they're all looking at the exact same underlying open files. You own the data, the vendor. That gives you massive strategic leverage when negotiating contracts.
That is huge. Okay, one last tool in the kit to cover. In-database machine learning. Things like BigQuery ML or Snowpark.
This is a pure efficiency play. Traditionally, if a data scientist wanted to train an ML model, they had to write a SQL query to extract the data, export it out of the warehouse, move it over the network to a separate Python environment, train the model there, and then write a pipeline to move the predictions back into the warehouse.
And as we learned with the shuffle, moving data is always the bottleneck.
Right. In-database ML flips the script. It says move the code to the data, not the data to the code. You can literally write a SQL query that trains a logistic regression model right inside BigQuery. You just type create model, specify the type, and it runs using the warehouse's massive compute cluster. No data movement whatsoever.
That drastically reduces the pipeline complexity. You don't need Airflow jobs just to move data around.
And it reduces security risk. The sensitive customer data never leaves the highly secured vault of the data warehouse.
Okay, that is a serious toolkit we just went through. We've gone from row locking and Postgres to network shuffles and Spark to metadata layers and Iceberg. But now we have to talk about the elephant again. AI copilots. This is part 4, the new reality.
The absolute game changer.
So we have this document here, AI copilots, working smarter, not harder. Let's play devil's advocate for a second. I'm a new graduate. I look at GitHub Copilot. It writes code faster than me. It explains old code better than me. If AI handles all the actual coding, what do I actually do all day?
Let's break down the blind spots of AI, because they are massive, and this is where your career lives. First and foremost is context blindness. AI can effortlessly write a query to calculate active users based on login data. It scans your schema, sees a column called login date, and thinks, great, I'll just count distinct users who logged in.
Sounds perfectly logical. Select count distinct user id where login date is within the last 30 days.
It is technically correct syntax, but it's a massive business failure. Why? Because maybe the business definition of an active user requires them to have made a purchase, or maybe the active definition explicitly excludes users who are on a free trial.
Yeah.
Or maybe, and this happens all the time, the login date column is only updated for the web application, and it completely ignores the mobile app users.
Oh, wow. So the AI sees the schema structure, but it has no idea about the semantic meaning behind it.
Exactly. It creates a technically perfect query that outputs a wildly misleading metric. And because the code looks so clean and professional, you trust it. That is incredibly dangerous.
What's the second blind spot?
Architectural trade-offs. AI is trained on the entire internet. It sees a lot of complex Spark code and distributed systems architecture on blogs and forums. So it might look at a relatively small data problem and suggest a highly complex Spark pipeline, just because that's the modern way to do things. It lacks the judgment to say, actually, this is a one-time analysis for a PM. Just write a simple SQL view. Don't spend $5,000 of engineering time building a pipeline for a $50 question.
Right. It completely lacks a sense of cost versus complexity. It doesn't have to pay the AWS bill at the end of the month.
Third is data quality and nuance. AI fundamentally assumes the data in the table is clean and reliable. It doesn't know that the customer ID column suddenly has duplicates in it because of a bad code merge the software engineering team introduced last Tuesday. It will happily join on that column without a second thought.
And what happens when you do a join on a column with unexpected duplicates?
The fan out. You duplicate rows exponentially. Suddenly your revenue numbers double or triple in the output. The AI won't warn you that the numbers look weird. It just executes the logic perfectly. You take that chart, you report double revenue to the CFO, and you get fired.
That's a nightmare scenario. And finally, what's the last blind spot?
Politics. AI cannot navigate which specific team owns which data set. It doesn't know that you need to get explicit sign-off from the compliance team before you change the schema of the revenue table. It doesn't know that Bob in accounting gets incredibly cranky if you change the column order of his favorite report.
At the end of the day, relationships are still human.
Exactly. So this leads directly to the new interview question. You are sitting in an interview for a senior role, and the hiring manager leans back, crosses their arms, and asks, if AI can write any query in seconds, why should we hire you?
That feels like a total trap.
It is a trap if you answer it wrong. If you get defensive and say, well, I write better code than AI, you lose.
Yeah.
You just sound out of touch.
So what is the winning answer then?
You fully acknowledge the power of AI. Don't be a Luddite. You say, AI is amazing. It handles mechanics. It makes me 10 times faster at the boilerplate. But then you immediately pivot to your value. You say, AI writes queries. I solve business problems. I define the metrics. I validate the data anomalies. I apply the business judgment to know if the result actually makes sense in reality. And I navigate the organization to get the solution adopted. AI is the engine, but I am the driver.
AI writes queries. I solve business problems.
I love that. That really is the bummer sticker for this entire deep dive.
It completely changes the conversation from can you type to can you think.
All right, let's move to part 5. This is the heavy lifting of the episode. We have 5 business scenarios pulled from the Business Problem Deep Dives document. These are explicitly designed to simulate a high-level technical interview or just a real crisis at work. I want to role-play these a bit. I'll be the stressed-out stakeholder, and you be the architect.
Let's do it.
Okay, scenario 1. The retention drop mystery. It's a Tuesday morning. I am the CEO. I storm into your office and I say, retention dropped 10% last month. I saw it on the high-level dashboard. I need answers by Friday or heads will roll.
Classic panic situation. Extremely high stress.
The junior analyst immediately rushes to their terminal. They open Snowflake. They start writing select star from retention. We're trying to find the exact number. They are frantically looking for the bleeding. What does the architect do?
The architect doesn't write a single line of code yet. The architect stops the panic. They sit the CEO down and ask clarifying questions.
Like what? What do you ask a panicked CEO?
First, what exact definition of retention are we looking at on that specific dashboard? Is it users not logging into the app? Is it users not paying their monthly invoice? Or is it users explicitly clicking the cancel subscription button?
And the CEO says, I don't know, the graph is just red.
Right. So I need to dig into the definition myself. Then I ask, is this 10% drop in absolute total numbers? Or is it a percentage rate drop? Did we change anything in the core product last month? Did the marketing team run a massive new campaign? Did engineering change the way we log tracking data?
You're fully diagnosing the patient before you even pick up the scalpel.
Exactly. Because here's a real war story for you. I once spent 3 full days investigating a massive churn spike. It turned out the active user definition in the warehouse relied on a specific last login timestamp. The front-end engineering team had pushed a minor code update that accidentally broke the logging for that specific timestamp, but only on Android devices.
Wait, so the users were actually still there?
Yes, they were completely active, they were buying things, but the event data said they were gone. If I had just queried the table blindly, I would have confidently reported to the board that churn was way up. The actual correct answer was just, our logging is broken.
That is a massive difference in outcome. So what is the architectural solution approach to this scenario?
It's a hybrid approach. You do a very quick SQL check first, just to validate the data quality. Is the drop across all platforms or just Android? Is it real? Once you confirm the data is mostly real, you don't just look at aggregates. You perform a cohort analysis.
Walk us through what a cohort analysis actually means in SQL.
You don't look at the giant bucket of all users. You group or cohort users by the specific week or month they signed up. Then you track their behavior over time relative to their start date. You might find that retention is perfectly fine for 90% of your user base, except for one specific cohort. Users who signed up last week from a brand new marketing channel.
So the narrative shifts. It's not overall retention is down. It's the new batch of users we just bought from TikTok ads are extremely low quality and they bounce immediately.
Exactly. And that insight is highly actionable. The lesson here is that the communication strategy matters just as much as the SQL syntax. You have to translate cohort analysis shows degradation in segment B into business English. Stop spending our ad budget on TikTok.
Scenario 2, real-time personalization. I am the product manager this time. I say to you, I want instant recommendations on the homepage. When a user clicks a picture of a red shoe, I want the very next page load to show matching red socks immediately. Sub-second latency.
This is a classic I want everything right now product request. The architectural trap here is latency.
So what does the architecture actually look like?
It's rarely one single tool. The architect knows this fundamentally requires a multi-layer solution. First, you need streaming SQL, something like Flink or Kafka streams, just to capture the live click. You need to know they just clicked the red shoe right this second. Cannot wait for an hourly batch job to process that.
The user is sitting there waiting for the page to load.
But you also need deep history. You need to know this specific user, usually by a size 10, and historically they prefer wool over cotton. That 10-year history is sitting in your massive data warehouse, taking up terabytes of space. You absolutely cannot query a cloud warehouse in sub-second time for a web request.
Yeah, Snowflake takes a second or two just to spin up the compute cluster. That's too slow for a web page.
Exactly. So you need a middle layer, a fast lookup database, a key value store like Redis or DynamoDB.
So how do you wire those three completely different things together?
It's a continuous loop. Step 1, a heavy batch job runs in Spark or Snowflake every single night, calculating everyone's historical preferences, and pushes those static preferences into Redis. Step 2, the streaming pipeline in Flink captures the live red shoe click. Step 3, the web application queries Redis, combines the live red shoe context with the size 10 historical context, and instantly renders the socks.
So the customer-facing web app never actually touches the data warehouse directly?
Never. That would be total suicide for app performance. The architect always buffers the heavy lifting. But there's a massive trade-off discussion to be had here too. Do you build the complex machine learning version of this right out of the gate?
I feel like based on everything you've said, the answer is no.
Correct. The architect pushes back and says, let's start with simple, hard-coded SQL rules. If they click a shoe, show them socks. Measure the actual revenue impact of that feature. If it makes money, then we invest in building the complex ML model. Don't spend 6 months building a Ferrari pipeline when you just need to drive to the local grocery store.
Start simple, prove value, then iterate. Okay, scenario 3, the data migration. This one is universally painful. We are moving from a massive on-premise SQL Server 1 that's been running the company for 15 years into the cloud.
Ah, the Big Bang migration, the absolute graveyard of data engineering careers.
Everyone always wants to just rewrite everything from scratch and go live on Monday. They say, let's clean up all the technical debt at once.
And that is exactly why 90% of migration projects fail catastrophically. If you try to change the underlying platform and rewrite the SQL code and update the business logic all at the exact same time, you will never, ever finish. You will uncover undocumented edge cases from 2014 that literally nobody at the company understands anymore.
So what does the seasoned architect advocate for instead?
The phased migration, sometimes called the strangler fig pattern. Phase 1 is strictly lift and shift. Take the database exactly as it is, technical debt and all, and simply move it to a managed service in the cloud, like moving an on-prem SQL server directly to AWS RDS.
You aren't touching the code at all.
Ideally, not a single line. You are just changing the physical computer it runs on. You minimize the variables. If something breaks on Monday, you know for a fact it's an infrastructure or networking issue, not a logic bug.
Okay, get it stable in the cloud first.
Phase 2. Add the cloud warehouse. Now that you're in the cloud, start replicating the data over to Snowflake or BigQuery specifically for the analytics teams. Now they can run those massive, heavy reports without locking up the transactional database.
Separation of concerns. You fix the performance issue without breaking the app.
Exactly. Then, and only then, comes phase 3. Modernize gradually. Break off tiny pieces of the monolith one by one. Say, okay, this quarter, let's rewrite just the inventory reporting system. Do it one piece at a time.
The key insight here seems to be extreme risk management.
Yes. The architect is highly risk-averse when it comes to core system stability.
Yeah.
You avoid the big bang at all costs.
Scenario 4, the slow ML pipeline. We have a fraud detection model. It is highly accurate, let's say 95%, but it takes 30 seconds to actually score a transaction. Customers are just staring at a spinning processing payment screen, getting frustrated, and abandoning their shopping carts.
30 seconds is an absolute eternity in e-commerce. You are actively losing thousands of dollars every second they wait.
But the data scientist is defensive. They say, but the model is incredibly complex. It uses 500 distinct features. It has to be this slow to be accurate.
The architect steps in to objectively profile the bottleneck. In almost every case, it is not the model inference, the actual math of scoring that takes 30 seconds. The math is fast. The bottleneck is the feature computation.
What do you mean by feature computation?
To score the transaction, the model needs contextual data. It needs to know how many times has this specific user bought from us in the last 365 days. If your system is calculating that number on the fly, running a massive select count star query on a billion-row transaction table, every single time someone clicks the buy button, it is going to be incredibly slow.
It's literally calculating the universe from scratch every single time.
Yes, it's terribly inefficient. So how do you fix it architecturally? You pre-compute.
Explain how that works in practice.
You use a heavy batch job, maybe Spark SQL, to calculate that rolling count for every single user every night or every hour. You store the final result in a fast lookup table. There's Redis again.
So when I click buy, the system doesn't do any math. It just looks up my user ID and sees the number 5.
Exactly. You fundamentally turn a massive calculation problem into a simple key value lookup problem. Latency drops from 30 seconds down to 30 milliseconds.
That is pure architecture.
Yeah.
You're optimizing the physical flow of data, not just rewriting the code to be slightly faster.
Exactly. It's understanding where the computational cost actually is and time shifting it to a cheaper, less critical time, like an overnight batch run.
Last one, scenario 5, the just build a dashboard request. The VP of marketing comes to you and says, I need a dashboard of everything, every metric, every channel, every demographic, and I need it by Monday.
The classic trap. If you just say, yes, absolutely, you will build a cluttered, unusable mess. I call it the Winchester Mystery House of dashboards. It will have 50 different drop-down filters. It'll take 3 minutes to load, and absolutely nobody will ever use it after the first week.
So what is the architect move here? You can't just tell the VP of marketing, no, I won't do it.
You perform discovery. You sit down with them and ask the most powerful question in data. What specific decisions are you trying to make with this dashboard?
That entirely shifts the focus from the output to the outcome.
Usually they don't actually need everything. When you push them, they really just need to know 2 things. Which specific ad campaign is currently wasting our money, and where should I reallocate my next dollar of spend?
Yeah. So you identify, 3 to 5 core metrics that answer those questions.
Exactly. Start incredibly simple. Build a clean, fast dashboard that strictly answers those specific questions. Here is your cost per acquisition by channel, sorted highest to lowest. That's it. Let them use it.
And then you iterate based on what they actually ask for next.
Exactly. If you throw 50 charts at an executive, cognitive overload kicks in and they will ignore all of them. It's about empathy for the end user. Understanding their cognitive load, the architect curates the experience, the typist just dumps data onto a screen.
Okay, we have thoroughly covered the framework, the physical tools, and the crisis scenarios. Now, let's transition to the actual interview room itself. Part 6, interview tips and the vocabulary shift. This is highly actionable advice for anyone interviewing tomorrow morning.
Let's equip the listener to sound like a senior strategic hire. not a junior coder.
In the document titled Interview Mastery, there is a whole section on vocabulary swaps, how to literally sound like an architect. Let's do a quick rapid-fire game. I will give you the junior phrase, and you give me the architect phrase.
I love this. I'm ready.
Okay, stop saying, I know SQL really well.
Start saying, I solve business problems using SQL.
Yeah, subtle but powerful. Yeah. Stop saying, my query is really fast.
Start saying, this solution meets our internal SLAs and optimizes our cloud compute costs.
That is so good. Optimizes cloud costs. That just sounds expensive and important.
It sounds like you actively care about the company's profit margins.
Right.
Directors and VPs absolutely love that.
Stop saying, the data is currently stored in Snowflake.
Start saying, we deliberately chose Snowflake for this workload because of its separation of compute and storage, allowing us to scale analytics independently.
Do you see the difference there? One is just stating a passive fact. The other is explaining a strategic architectural decision.
Exactly. You're constantly explaining the why. You're showing intention behind every technical choice.
We also really need to talk about the STAR method for answering behavioral questions.
Situation, task, action, result. Every candidate knows this framework by now. But here is the architect twist that most people miss. Focus heavily, almost disproportionately, on the result and the specific metrics.
Give me an example of a bad versus a good result.
A junior says, so I rewrote the SQL joins and I fixed the pipeline so it didn't crash anymore. An architect says, I optimized the physical execution plan, which reduced data latency by 40% and explicitly saved the company $10,000 a month in AWS compute costs.
Numbers speak infinitely louder than code.
Always. Executives speak the language of money, risk, and time. If you can directly translate your SQL optimizations into money saved or time gained, you win the interview.
And finally, at the very end of the interview, the manager always asks, do you have any questions for us?
Never ever say, no, I think you covered everything. That is the absolute kiss of death for a senior role.
So what should the architect ask?
Ask questions that demonstrate high-level strategic thinking. Ask, how does your engineering team choose between using Spark versus Snowflake for different workloads?
That shows you already know there's a complex choice to be made there.
Exactly. Or ask, what is your team's philosophy on integrating AI copilots into the daily data workflow? This shows you aren't afraid of AI, you are forward-thinking. Or my personal favorite, what is the single biggest data quality or governance challenge the team is facing right now?
That shows you are a problem solver stepping into their world, not just a ticket taker waiting for instructions.
Those questions completely change the dynamic of the room. Suddenly, you aren't a subordinate pleading for a job. You are a peer discussing high-level strategy with another professional.
As we wrap this up, I want to zoom out a bit. Part 7, closing thoughts. We've talked extensively about all these shiny new tools, AI copilots, Snowflake, massive lakehouses. But looking at the historical context document, the SQL story, it's actually amazing that SQL as a language has survived for 50 years.
It really is a miracle of computer science. Think about it. It completely outlived the massive NoSQL hype cycle. Remember 10 years ago when everyone confidently said MongoDB and document stores would kill relational SQL?
Oh, remember that? We were all supposed to switch to JSON for everything.
It completely outlived Hadoop and MapReduce, which were incredibly complex. And honestly, it is currently outliving the initial panic of the AI hype cycle.
Why is that? Why won't this 50-year-old language just die?
Because it is the perfect logical abstraction. It explicitly separates the what from the how. In SQL, you just declare, I want the total revenue for active customers in Chicago.
Yeah.
You don't tell the computer, open this specific file, jump to memory sector 4, read this byte, loop through, and check if it matches the string Chicago.
Right, you describe the desired result. You don't dictate the procedural process.
Exactly. And that beautiful abstraction allows the underlying physical technology to radically change without breaking the language. The execution engine can change from a 1980s mainframe to a 2010s cloud cluster to a 2026 AI brain. But the language, the fundamental way we frame the business question, remains exactly the same.
So AI is really just the next evolution of the how.
Yes. AI makes the how infinitely easier. It significantly lowers the barrier to entry for just writing the syntax. But ironically, that just makes the architect's job of knowing what to ask significantly more valuable. When literally anyone can generate a perfect query in 2 seconds, the person who knows which specific query needs to be generated becomes the most important person in the entire company.
I think that is the perfect place to land today. But I do want to leave the listener with one final, slightly provocative thought to mull over. If AI has completely mastered the how And we as architects are currently mastering the what. What happens in 5 years when autonomous AI agents start figuring out the what on their own? What happens when the machine starts defining the business problems without us? If we're moving from how to what is the next frontier for us, just purely the why?
That is a deeply existential question.
Yeah.
And honestly, that might be the topic for our next deep dive.
To everyone listening out there, the typists are worried. And frankly, they should be, but the architects are incredibly excited.
Go out there and be an architect.
Thanks for listening to this deep dive. We'll see you on the next one.
Goodbye, everyone.